In this part, we're going to put all the things together that we've learned up to here and be able to run a full example together with our hardware, the firmware that we're going to program for it, and some client tools. So let's look at the hardware as it looks now. So this is the Industruino together with the Industruino Ethernet expansion module, and it's connected to USB to power it and to program it, and it's connected to an Ethernet network here. And both parts are connected, of course, so that they can communicate. And for this example, I'm using a sensor. This is a BME280 sensor, which is able to measure temperature and humidity. And it's from Grove, with a Grove connector, and I've used a cable that ends with these pins, and they're attached here to 3.3 volts ground, and there are two pins which are labeled SDA and SCL. That's for the I2C. That is they are connected here. Okay, so in the last part we've seen how to program firmware for this for a REST API together with the Arduino JSON library, Arduino HTTP server, and the custom LCD modules from Industruino itself. And we've learned a bit about WebThings and the WebThing API. Now we could program a WebThing API compatible implementation from scratch, or we could use the Thingstruction service to generate one, and I'm going to show you how. So for this, I go to the thingstruction.online main site and hit Get Started. So we could create a complete thing description from scratch, or we can use a predefined template. And I'm going to use the template, the humidity alerter. It measures humidity and compares it against defined thresholds. So select that, say Create from this template. Now I have to choose a code generation module, and there are a bunch of modules available. I filter for the Industruino and see the Industruino JSON REST API. I can select more information from here, and each module has a module details site where I can see additional information, for example, where tests have been run with this module, what dependent libraries are necessary to include within your IDE, and what the functionality is. Okay, let's choose this module. And the template predefines properties, actions, or events. And as we can see here, two properties are predefined. Humidity as an integer, that's the current humidity as a percentage. And there's a humidity threshold, also as an integer, so that our firmware is able to compare the actually measured humidity against this threshold and like trigger an event or something. I'm going to change that a bit here, do a typo. Great. Okay, next step, actions. This example includes an action flash LED, flashes the onboard LED, as we do not have an onboard LED on the Industruino and do not need it for this example. I'm going to delete that. Move on to events. And there is an event called humidity above threshold, and that is, of course, triggered when the measured humidity goes above the defined threshold. I'm going to leave that. Hit generate. On this page, I'm able to review the properties and actions and events that are created. Everything looks fine. So I'm going to generate. And what this comes back with is a bunch of code snippets that have been generated for me. First is the Thing API description in JSON. I don't need that right now. There is a sketch.ino, an app.cpp, and a README. And I can look at each of these files individually. I can download them, or I can view them in the browser. And the README tells me exactly what to do with it, how to copy, paste, import that into my IDE, implement application logic, and more. So that's what we're going to do. I open the Arduino IDE, which contains a blank sketch here, and I open sketch.ino to be viewed in browser. Say copy to clipboard, which takes all the text, copies it to clipboard, so I can paste it into here. And this is the part that contains all the basic network and HTTP handling, the JSON processing, and essentially everything that makes up the WebThing API processing stuff. So that's quite a lot, but we don't need to change anything here. That can stay as it is. So for the application level part, we have the app.cpp, and for that we need a new tab. It asks me for the name for the new file, and I give it an app.cpp. And open the app.cpp asset here in the browser, say copy to clipboard, and paste it here. So this is the application level part where for everything I entered in the model there is some sort of functionality here. For example, regarding the humidity property, I have an app get humidity function, and regarding the threshold there is an app get humidity threshold and app set humidity threshold. So all that I need to do is to fill out my own device logic here. And as I'm using a BME 280, I need to include some library for this and make it usable. And it's got a part here. It says hint, include your own libraries here if you need them. And I'm going to do that. Include the seed BME 280.h and a wire.h, and define your globals here, which I'll do this way. Class name is BME 280, and I give it this name. And the app setup function is called by the global setup after serial and networking has been established. So that's a good place to initialize my BME 280 sensor, calling BME 280.init. And as a first step, I would like to be able to just measure the humidity and query it using the WebThing API. For this, I locate the app.getHumidity function, and instead of returning 0, I'm going to return BME280.getHumidity, which reads the current humidity, returns it, and the rest, the WebThing handling, is done by the main sketch. Okay, so let's try to compile this. That went well, so next step is upload it to our board. Connect the board, hit upload. And it already had the firmware from the last sketch. So now it's flashing and uploading. And what it does is it connects to the network and prints its IP, MAC address, and other stuff. So the IP is 192.168.0.102, and it says, okay, WebThing API active. Great, let's test this. For testing, I could use curl from the command line, but for now I've chosen to use the Postman app, which is a nice API testing and automation app, really good for testing. So I just enter the IP here and make a GET request to /WOT, hit send, and gets back with 200 OK. And that's essentially the thing description. It's our humidity alerter, just as we modeled it, with its description. There are two properties, humidity and humidity threshold. Current humidity is percentage, and it has an href, so that's the URI of that specific property. And I can click on that, and it opens a new tab and inserts that part in the URL field. Hit send, and the current humidity is 57. And it says here on the display, as you can see, read property humidity. So that's what just has happened. I can now take this sensor and breathe against it. So that should alter the humidity. And if I again send this, yes, now the humidity is 82%. Again send this, it's dropping 75, 66, and so on. Now I want to be able to define a threshold which the device remembers and compares it against this humidity. And so there are functions to get the threshold and set the threshold. So what I do is I introduce a new variable above here. So static int humidity threshold, and I initially set it to 100%. Okay. The get function for that returns the threshold. The set function sets it. Okay. Upload again. Flashes. Great. So now I can get the humidity threshold property, and it's 100 as it is predefined, but I'm able to formulate a put request. Let's say raw, and I want the humidity threshold to, let's say, 70. Send, and it said, okay, write property, humidity threshold, that went well. So if I again query the humidity threshold, it's 70. Great, so I can send values to that device and it remembers it. So how to compare the current humidity against the threshold? There's an app loop function that gets called regularly by the global loop function. And I can put logic in here that, for example, compares values, and if the humidity is above the threshold, I can raise this event. This function has been predefined for me. So let's do this. First, I need to know if the state that I'm currently in is that it's above the threshold or not. So I need a global variable be above threshold, and it's initially false. And then within the app loop function, I need to compare or measure the humidity and compare that humidity against the threshold, but depending on the state that I'm in. And I'm going to paste the snippet in here because programming this manually would take too long. What we do is measure the humidity. If we're not above the threshold in the past, then we compare if the current humidity is above the threshold, then we raise the event and remember that it is that way. And we may use the LCD display here and put the cursor some lines down and print, okay, it's above the threshold. If we're above the threshold, then we compare if the current humidity went below the threshold and set the variable accordingly and emit a below string to the display. Okay, try this again. Good. So again, we need to set the threshold because we reset it, it's been back to 100, and body is still there, so I send this. Okay. There is a URI called events, which I can query for all the events that have been raised in the past. And there are none, because the humidity threshold is set to 100 and humidity is typically lower. We set it to 70 and again breathe against the sensor. And query the events. Yeah, there was a humidity above threshold event and it said above, but it's fallen below 70 and now it says below. And yeah, querying /what/events, there is one event that we had humidity above threshold, and that's not a real timestamp, but the time relative to the boot time of the device. So this is it. This is how to model a WebThing API, a thing description, generate code for that, throw it on that device, and test it using Postman.